We've had telescopes on the ground. From the 17th century into the 21st century. These ground telescopes are powerful. So why put telescopes in space? Space telescopes don't need to close at dawn as optical telescopes do. Space telescopes aren't affected by atmospheric blurring. The atmosphere limits which wavelengths can reach the ground. Space telescopes can see wavelengths blocked by the atmosphere. The wavelengths space telescopes can reach reveal unseen structures in the cosmos. The Hubble telescope sees infrared, ultraviolet, and visible light, and has an unparalleled record of discovery. Hubble was carried to orbit April 1990. By the Space Shuttle Discovery. Astronauts did 5 follow-up missions to make repairs and add features. Great job! The result: a 30-year legacy. Exploring the universe. Studying the life cycle of stars from their beginning in nebulae. To their end. Large stars create supernova explosions, often leaving black holes. Smaller stars make planetary nebulae, usually leaving white dwarf remnants. Astronomers predict that billions of years from now, our Sun will expand into a red giant, swallowing Earth. Then it will collapse, forming a planetary nebula, ultimately becoming a white dwarf star. Our galaxy, the Milky Way, contains over 100 billion stars and is 100,000 light-years across. A light-year is 6 trillion miles. Light travels 1 light-year per year. So we are seeing into the past. The Whirlpool Galaxy, M51, is a common spiral type, imaged by Hubble. Because it is 31 million light-years away, we see it 31 million years in its past. There are about 2 trillion galaxies in the universe. The Hubble Extreme Deep Field reaches 13 billion light-years into the past. This was our farthest view of the universe, until surpassed by the new James Webb telescope. The farther away we look, the more light shifts toward infrared, due to the universe itself expanding, stretching all wavelengths. To see farther than Hubble requires looking at infrared wavelengths. with a larger mirror, as the new James Webb telescope can do. James Webb. By cooling its sensors and shielding them from heat, sees longer infrared wavelengths than Hubble. James Webb has a beryllium and gold mirror made of hexagons, and 5 heat shields the size of a tennis court. The James Webb mirror folds up with the heat shields to fit the European Space Agency Ariane 5 rocket. Launched December 2021 from French Guiana, South America, on a multi-stage, million-mile voyage. Called home. Unfolded. And entered orbit. Not around Earth, but around a gravitational sweet spot, L2. On the opposite side of Earth from the Sun. In orbit, and with its sensors cooled to near absolute zero. James Webb sees galaxies that formed soon after the Big Bang 13.8 billion years ago. Like this one, 13.5 billion years old. James Webb's very first deep field image went beyond Hubble's best. As in this comparison, closer to home, the Southern Ring Nebula is revealed in greater detail with short infrared wavelengths. With longer wavelengths, we see it as a double star. One of the pair is dying. Infrared sensors see through dusty nebulae to witness the birth of new stars, as found in the Carina Nebula. From Galileo to James Webb, we explore strange new worlds. And boldly see what no one has seen before.